Hey, college algebra students, this is Dr. Demaray. I'm with two students, but we're working on lesson 4. We have lessons 2.1, 2.2, and 2.3 covered in other recordings, and now we're going to be addressing quadratic equations. So let's take a look at a couple examples. Now, this is coming from your homework that you are responsible for. I should be able to address a lot of the questions. I don't think I can hit every single one of these. I just want to give you a bigger picture of the whole how to do things. Now, it is your responsibility if you wish to have a calculator, but you don't need it for this particular question. However, I just want you to know that you always should have a calculator ready and available in case you are stuck on maybe basic stuff like multiplication and division. I mean, I get stuck on it too. I mean, so don't feel like, oh my God, I'm perfect. Nobody's perfect. I mean, we just try to do the best we can. So now it says right here, solve the following equations by factoring. Now, when we factor, there's a lot of strategies in factoring, and you learn those factoring strategies from, here, let me make sure. Yeah, you learn those strategies from 1033. And it's assumed at this level that you have some understanding or recollection of those strategies. However, I know many of you don't. You don't remember them. So what I've done was provided factoring strategies for you in another resource. You'll find that I made a PDF document, and I appreciate you looking at that. But let's go ahead and take and move this guy over because we want to get it so we can start working with the concept of factoring. So we want to get it isolated to one side of the equation. So what we do is switch the sign of that -5, bring it over, make it become +5. Now we're in the form of a trinomial, and that is good because that's the way quadratics are normally set up. So now what we want to do is ask ourselves, what two numbers multiply together to create this number that when added together gives us this number? So we go through the factors of 5. Now 5 is 1 and 5. That's 5. That's a prime number. So immediately we know it's 1 and 5 because 1 plus 5 is also 6. So that works out for our favor. So what we do is we set up a set of parentheses like this, and we have it be opened up by y's. And then we're going to go ahead and put a +5. It doesn't matter if we put the +1 here or the +5. And then we're going to put the other number over here. And then we're going to set it equal to 0. Now to solve the equation, to solve it for y, what you do is you set each product equal to 0. All right? It's called the zero product property rule. Is that whatever you're multiplying together that creates a 0 is going to be set equal to 0. So we set this equal to 0. And then we solve for it. Well, we don't really need to do much. We could just go ahead and take the 5 and move it over to the other side, and y equals then -5. And then we do likewise the same thing for the value of y plus 1. We do y plus 1 set equal to 0, and then we just simply move the 1 over and it becomes this opposite. So y equals -1. So the answers that we're looking for is -5, -1, and then we answer it as such. Okay, pretty easy to do that. Now, what's great about the MOM is that there are also embedded in here videos that you can watch as well as written examples. So if you're stuck on something, then watch that again, and you can see you can get the additional support that you need. All right. Now, let's take a look at this one. So we're looking at factoring again. Now, I'm automatically going to bring the 2 over. Please understand, I'm following the same model as I just did over here, where I'm bringing the -5 over. So I'm going to make that as -2. Because I want to set it equal to 0. I don't want to have to keep on writing it over again. All right. So now, let's go ahead and take a look at this. Now, we could try to answer that question, as I did before. What two numbers multiply together to create this number that add up to this? But we have a situation here. We have a leading coefficient. And when that happens, I call this a complex number system or a complex trinomial. Now, although that's not the official term for it, but it's complex because it's going to make it a little bit more difficult that we have a leading coefficient. Now, you may have learned through high school or through other intermediate algebra or through other teachers about the guess and check method. There's the trial and error, they call it. And then there's other strategies that you have. Now, I'm going to use my own set of strategies. So you're going to have to go ahead and yield to whatever works for you, whatever you recall. But this is the AC method and bottoms up. So I'm going to do that with you right now. So here, the way to solve this is by multiplying these two together and put it as an X like this and put the -5 here. Now, you have to ask yourself what two numbers multiply together to create -6 that add up to -5. And so it is, we have -6 and +1, because that adds up to -5, but also multiplies together to create -6. Now, what you do is you go ahead and take those two circled numbers and you place it over the leading coefficient. All right? You place it over the leading coefficient. So I have this -6 over 3, as well as I have 1 placed over 3. And then I go ahead and reduce my fractions if I can. So I have 3 goes into -6, -2 times, and that's over 1. And I'm leaving it as a fraction on purpose. And this does not reduce at all. The 1/3 stays 1/3. Now, to conclude this factoring, all I have to do is bottoms up, and that is put the 1 in the front and put the second number on the top, all right, or I should say the numerator, put second with its sign, and you have your factor of the first one. Now we have to do the same thing for this one. Bottoms up, the 3 becomes our leading coefficient of the y, and I have a +1 for the value of my second number. And I set that equal to 0. So that's how you factor complex trinomials in the easiest way possible that I could imagine. I've taught this multiple different strategies, none of which have been able to serve the student better than that. Now, if you were to re-multiply this out, you would in fact get the same trinomial here. Now, once we're done with that, we know that we have 1y. We're going to say each equal to 0. So y minus 2 equals 0 means y equals +2. And then 3y plus 1 equals 0. We would move this 1 over. It becomes 1. That's -1, that is. And then, of course, we have then 3. Now, you probably are wondering, well, once you do this, can I just go ahead and immediately get to the answer? And the answer is yes, so long as you switch the signs. If you switch the signs, then you'll be fine. Like -2 over 1 now becomes +2 over 1. 1/3 becomes -1/3. And then you would, in fact, get the right answer. Okay? Really kind of a powerful thing to think about. So if we look at the answer here, all right, the answer is exactly what I gave you, 2, -1/3. Now, be mindful that your answer does not matter if you put the -1/3 first and then the 2, it would get you marked correct if you did it either way, all right? Now, that perhaps is a new way of looking at how to factor complex trinomials, which is very, very powerful for a lot of you who are very stuck on factoring trinomials. So now let's take a look at this next one. Okay. So now the thing with this one is that it does not have a constant in its problem set. All right, so we have just going ahead, looking at this, we could factor out an m immediately. And when we do, all right, we get this. Now that we have that, we can go ahead and set each factor equal to 0. So m equals 0, as well as m equals -15. Really fast problem right here. Okay, that one's a little easier than the last. And likewise, we would do very much the same thing with this one. Okay, we would go ahead and factor out what we can. So I'm going to go ahead and write the problem down. we'd factor out an x, as well as factoring out what can go into both of these is 2. All right, 2 can go into both those, so we're going to factor out a 2 and put down 8x plus 7. And now our answer is x equals 0, because if you take, here, I'll write this down real quick. If you put 2x equals 0, wouldn't you just divide both sides by 2 and get 0? So I kind of did that mentally real quick. Now we do the same thing for this one. Now, what I want to try to do is transition your mind to think quickly about this. All you got to do is take the opposite of this number here. So I'm going to take the opposite of that number is -7 and put it over 8, and I'm done. There's my answer, is 0 and then -7/8. And there's the answer that I'm giving you. So as much as I am going pretty quick about this, it is not impossible. I'm using very simple strategies to help you understand how to go about doing these problems. Now let's take a look at this one. So we have 6t minus 29 equals 1. We don't have a variable with this one, so we're going to go ahead and bring this over to the other side, make it become 30. Because 29 added to 1 is 30. And then we're going to divide both sides by 6. All right, that's 5, not 6. I was beginning to write 6, by the way, because I was writing the denominator again. Anyway, so 30 divided by 6 is 5. And now we're going to go ahead and take the square root of both terms. Now, when we take the square root, we must use plus or minus sign next to the square root symbol. We can't take the square root of 5, so we're going to leave it as plus or minus square root of 5. And that is our answer. Now, obviously, you should know, and if you don't, I'm here to tell you that when you write this, the system does not allow you to write a plus or minus sign. It would be a lot easier if they did. But you should understand that that is negative. All right, negative and positive square root of 5. So I just want you to point, I'll be pointing it out that this is what you would expect to put into the system. All right, now solving the quadratic square root property. All right, so this is the square root property that we're using, by the way, just so you know. So this is how you go about solving these quadratics. Now, looking at this one, to clear a square, you have to square root. When you do square root, you must use the plus or minus sign to represent that process. Now, once you do that, then it's going to become n plus 7 equals plus or minus square root of 11. Now, we go ahead and subtract 7 from both sides, so n equals -7 plus or minus square root of 11. And there, you would have to write it as two separate problems, -7 plus square root of 11, and then -7 minus the square root of 11. And that is the answer that we have here. All right, so we're doing the square root property. Now, this is no different. You would go ahead and subtract 39 for both sides. You divide by both sides by 2, and then you would go ahead and square root both sides, and then subtract 10 from it. And when you square root it, it's plus or minus. All right, so again, I can't go over every single one of these problems because I do have students here and they wish me to do it. I will do it. However, if they don't speak up, then I will not go ahead and do something unless they feel that it would help them, and that means help you. All right, this is being recorded, so I have the advantage of having students while I'm doing this recording. I know how to use students. So, ladies, if you need me to do that, let me know. Number 7, I'm going to skip over a couple of these. Number 8. Now I want to do the quadratic formula. Okay, so that's a little different. Now number 9. Okay. When we're looking at number 9, the quadratic formula is imperative that you recall the quadratic formula. So x equals, okay, negative b plus or minus the square root of b squared minus 4ac all over 2a. You must lock that up into memory. You have to get that into your memory. All right. Now, when you are working with the quadratic formula, it is imperative that you understand that a quadratic needs to be written in the form of a quadratic equation, which is this form right here. Okay. That is the form of a quadratic. All right. Now, this particular question is written like that. So you have 2w squared plus w minus 4 equals 0. Now, this means a is equal to 2, b is equal to 1, and c is equal to negative 4. That is what we have. So we're going to go ahead and plug that into the equation here to represent those numbers. So we have b is 1, so it's going to be negative 1, plus or minus the square root of 1 squared is 1 times 1 is 1, and then minus 4 times 2 is 8, all right, times negative 4 is positive 32. All right. Now we have that all over 2 times 2 is 4. All right. Now we're looking at this as, okay, we're using the quadratic formula. We see that this is 33 because 1 plus 32 all over 4. And there's nothing I can do with the square root of 33. 33 is 11 times 3, both of which are prime numbers. I can't find a perfect square that can go into them. Therefore, this is the answer that we're looking for. Now, we can write it in 2 different ways. We can write it as negative 1 plus square root of 33 over 4, as well as comma 1, negative 1 minus square root of 33 over 4. But for the most part, we have the answer. Okay. I like the plus or minus sign myself, but we got to follow and adhere to the fact that this doesn't like plus or minus sign. All right, so that is the quadratic formula. Okay. Now the quadratic formula, you'd follow the same exact structure all the way through using the quadratic formula. I show you one, I show you them all. I mean, now the key thing that you need to know is that you have to make sure that you reduce your or simplify your radical. If that was, let's say, 32, for example, this day 32, and rather than having the 1 added to it, 32 is the factor of 16 times 2, and the square root of 16 is 4. That could be simplified. Okay. So again, I say to you, if it was the square root of 32, 16 can go into that 32 2 times. Therefore, this would be 4 radical 2. So there are times, excuse me, I'm zoomed in a little too far, excuse me. But I want you to know that square root of 32 is 16 times 2, which then could be reduced to 4 out on the outside radical 2. So you are looking at a different situation. However, this is a unique value system to that. So I just want you to be aware, though, if you're ever dealing with radicals and you have, structures of numbers that can be broken down into with perfect squares in them, you must do so. You can't leave them unsimplified. So, and that is probably the biggest dilemma of students using the quadratic formula. They don't know how to simplify radicals, so they get stuck. All right, now, is either one of you need me to go over another question regarding the quadratic formula? All right. Thank you, Monica. All right. Now, I'm going to go ahead and look at this one. All right, great. Alana's good too. All right, I appreciate that, ladies. It makes, if you two know it, and perhaps a lot of students know it, and if you don't remember it, then you might go back to old, notes, or go ahead and do a little bit of research on simplifying radicals from the internet. Just type in simplifying radicals, and a lot of YouTubes will come up on it. All right, now, solving the following equation using the preferred method. Now, you have any choice of the way you solve these things. Now, there is completing the square method, for example, which I'm going to get into in just a minute. But there are multiple ways that you can solve for things. You must use whatever strategies that you find that can support you getting to the answer. That is ultimately what we're looking for. I would say and caution any one of you who thinks that using the quadratic formula is their safest bet, because it is prone to errors. Errors occur a lot in using that structure, okay, just so you know. All right, now, I don't think I really, okay, so now it says solve the rational equation, enter solutions in comma separated list. If no solutions exist, enter D and E. Okay, now, when solving for these kinds of questions, a little different from the ones that we were doing before, using any methods we wanted and all that. So we're going to have to take a look at solving these. So let's take a look. All right, now, the thing that we want to do is we want to get rid of fractions as soon as possible. And we recognize that this is the difference of two squares right here. And because this is the same exact values as what we have here and here, we're going to choose to multiply both sides by the same thing as we have here. Now, this is the difference of two squares. So this is this, right? So when I go ahead and multiply this times this, one thing you have to get used to is the fact that this will completely wipe out this when I go ahead and multiply it out. All right, leaving you with simply 6x. Now I hit reset on this combination, and then this will wipe out this, and leaving me with +1, because this is a plus sign, +1 times this. So that leaves me with positive, and then I'm going to put in parentheses just to make emphasis to the fact that what's been moved or completed was that this took out this, leaving me with this times that. So I get this. Now I do the same exact process over on the other side. This will wipe this one out, and I hit reset, right? It's over here. I don't know. I mean, sometimes it's not necessary to write all this junk. I hate writing more than I have to. This is unnecessary to write this, by the way. This will wipe this out, and then this will multiply that. So that leaves me with this. I wrote it down just because I know some of you are like, you can't keep up with me because you're so afraid of math, and you're really intimidated by the whole process, so you just give up. And that's just not good attitude. So anyway, this wipes out that, leaving you with this times that, and x plus 3 times 1, that shouldn't even threaten you. So now we have to go ahead and combine all of the like terms and isolate for the variable. So the parentheses are insignificant, not necessary at all. We don't even need the parentheses at all. So we're going to just imagine they're not even there. And I'm going to have 6x added to x gives me 7x, but I have an x over on this side, so I'm going to subtract that x. In other words, look at this. I can do this. All right. And that leaves me with then 6x. And then I'm going to go ahead and add 3 to both sides, leaving me with 6. So x equals 1. Now, the thing I have to do in this case, because we're dealing with rational equations, is I have to make sure that I check this answer, that it does not interfere with a domain restriction. And here's what I mean. If I came up with the answer of 3, then 3 minus 3 gives me a 0, and therefore I couldn't do it. I'd have to throw that answer out. That's called extraneous answer solutions. In this case, I'm pretty confident that this number will work. So my answer is 1, and there it is. All right. Now that took a lot for me to explain to you because I'm doing it in such great detail, and I'm hoping that it works for you. I'm going to do that again. Okay, I'm going to do it one more time, so that way you can understand it and hopefully have a strategy set to complete these. So we have this. I really wish this was stronger. Okay, anyway. Now, I'm going to go ahead and factor that bottom trinomial there before I even write it down. And I'm going to ask myself, and I'm going to use the arrow to point it out, what two numbers multiply together to create negative 15 that add up to negative 2? Well, I know that negative 5 times positive 3 is negative 15. And I know that negative 5 added to positive 3 gives me negative 2. So therefore, I write it down. And recognize something of a familiar activity going on here. Here, they had it where they had a factorable perfect square, or different squares, excuse me. But they had that where we can factor to the same exact values that were already listed. And likewise, they did the same thing on this one. So now what I'm going to do is multiply both sides by exactly this. So I wrote it over there. I'm going to write it over here on a slant. It's not a plus sign, by the way. Just an accident. Okay, anyway. So now I'm going to go ahead and multiply it out. When I multiply this times this will wipe that out, leaving with x times this. So look how I do it. I write it as this times the x minus 5. And then this is going to cancel this out, leaving with negative 1 times x plus 3. And then this will all cancel this out, leaving with negative 10x plus 18. All right, so I have that all now done. Okay. Now we're going to go ahead and do the distributive property and clean up some things here. So x squared minus 5x minus x minus 3, because I'm did the distributive property, and then negative 10x plus 18. Now I'm going to continue bringing things together. This is going to give us negative 6. I bring negative 10 over, it becomes positive 10. So that's going to be positive 10 added to negative 6, which is positive 4. You should be able to do that in your head. So you have negative 6 plus 10 gives us positive 4. Now I'm going to go ahead and subtract 18 from both sides. I'm going to get negative 21. It equals 0. All right. Now I have to ask myself, what two numbers multiply together to create negative 21 that add up to positive 4? And we think of 7 times 3. So we have positive 7 and negative 3. Why positive 7? Because 4 is positive and we need them to add together to create positive 4. So now I have my answers, and my answers are x equals negative 7 as well as x equals positive 3. Now the thing is, we've got to double check this to make sure that these are not domain restrictions, and they're not. We have a positive 3, not a negative 3. Okay, so we are good to go on those answers. Now you can go ahead and double check it if you don't feel that comfortable. You can always double check to see, but I always look for domain restrictions and see if whether or not it breaks those, and then move forward. And you can see here that 3, -7 is in fact the answer. All right. Now, the other two questions are following suit. You would do the same thing. All right. You would go ahead and factor this out. Most likely it's going to be, and it is, it's going to be x minus 7, x plus, or x minus 8 is the factor form of this. And then you're going to go ahead and multiply both sides by it. So it follows exactly what I just did in this problem set. Now, however, this one's a little different. All right. And so it is, because it's different, I'll show you how to get where you multiply it so you can get rid of the denominator. Is this helpful for you ladies? Does this help what I'm doing? All right, great. Excellent. So I'm trying to create habits for them as I am for all my students. Right now we have a P represented, a P plus 2, and a 9 represented. So what we want to do is simply just multiply all of them together, because that's what you do when you have all so uniquely different. Over here, they were kind of the same. You can see that they were the same, and we were able to go through them quickly. However, this one does not have any familiarities to each other. So what you do is you multiply both sides by 9p, p plus 2. And what you do is one side, you do the other. So that's 9p, p plus 2. Now, I go ahead and do that. I distribute this out to this, and the p's will knock each other out, leaving me with 9 times p plus 2 times 1, and that means it goes away, because 1 times anything itself. And then I do the same thing for this. Now, this is going to knock this out, leaving me with 9p times 1. Whoops. So I got 9p. All right, 9p. And then the 9s will knock each other here, so leaving me with p times p plus 2 times 1, which is simply just p. And you can see all the fractions are gone now. The rest of it is just simple legwork. You're just going to go ahead and multiply it out. This is 9p added to, I'm going to put the 9p's together. 9p, and then you have plus 18 equals p squared plus 2p. And then you're going to go ahead and bring everything over to the left side or right side. So this is going to be 18p's added to, or no, subtracted from 2p's. So you're going to get p squared minus 16p minus 18. Now, I purposely brought everything over to the right side versus bringing it to the left, because I want my leading coefficient of p squared to remain positive. I don't want that to be a leading coefficient of a negative value, because now I just go ahead and ask myself what two numbers multiply together to create negative 18 that gives me negative 16. Now, I think about that. You're talking about multiplying together to create this to add up to this. So you have 2 and 9, you have 3 and 6, and that's all that I know of. And then 1 and 18. So this one you're going to need a quadratic equation for. This one's going to be a complex structure. All right, this one's not going to be as easy as just throwing it together, and that's why the answer is what it is. So you can't factor this one. You have to use the quadratic formula, and which I attest to the fact that, no, I will say that most students know how to do it, but I'm telling you why you would use the quadratic formula right away. Okay, so that is lesson 2-4A. All right, there's a lot going on here. So this is 2-4A.